Hello, my name is Tony. Thanks for coming. I will do this presentation to talk about the integration of solar photovoltaic and battery energy storage systems in power distribution network. We'll talk about reduce the cost and extract maximum power from hybrid energy storage system. The contents of our presentation, it's the importance of this research, key point of this research, the research design, advantages, disadvantages, and reference. In recent decade, hybrid renewable energy sources coupled with a battery pack have been mostly used to upgrade providing of power distribution. What is a hybrid power system? Hybrid power system is combining multiple sources to deliver non-intermediate electrical power, such a photovoltaic model, wind generator, and sometimes diesel generator or other stuff of energy production. And we'll regulate it all with backup system. It's a battery bank. The battery energy storage system value streams can be combined for extracting the most value possible from the system. So when we charge this battery, we can extract the maximum power of it. In the current going market, the most value for the utility is coming from regulation of frequency, capacity, and in other cases from capital deferment. In the coming future, as the markets will become saturated from the competition of distributed resources, of energy, and further fall in price of BESS, the beneficial combination of value stream to be used will all be dynamic, varying by time of day, region, and season. Also, battery chemistry technology improvement will make concern about the operations of battery, which is irrelevant. Longer calendar life, higher cycle life, and cheaper. The key point of literature is simple moving average based smoothing solar power generation. We will talk about it. Moving average with single and half window battery energy storage system. Energy compensation with single and half window load leveling. Hybrid energy storage system reactive power support, and performance of proposed smoothing strategy. What is simple moving average based smoothing? What's this technique? In this technique, a moving window based algorithm is used. The algorithm decides a target power at each point of time. The battery power is a difference that it receives between the target power and the actual power output from the battery power. It is observed that the smoothing curve obtained is smoother with a high average window size leading to high battery size. Moving average with single and half windows, another technique. Since the target power closely follows the solar PV output, there is a reduction of battery storage requirement. Battery state of charge changes significantly to another level during day's end. Hybrid energy storage system is really important. Why it's important? It's important to avoid fluctuation of energy, of power system. It will show you significant performance of energy of grid. Flexibility to upgrade the power. Get maximum energy from hybrid energy storage system. And the most important thing is reduce the cost of energy. All the above lead to think about how to reduce the cost and extract the maximum power of energy from hybrid energy storage system. Our research design is for dispatching the power demand on the hybrid energy storage system and extract the maximum power. We have to follow these steps. First of all, we have to minimize the overall loss of hybrid energy storage system. And we have to focus on the introduction of backup energy storage system in improving the major issue, like the rise in voltage or voltage regulation. As well, reserve the power and the flow, like changing the lamp and the power, and use the maximum power during the day or during a specific time in the day. Ramp rate is a term used in power generation to express how quickly a power plant's power output is changing. Is it ramping up, increasing, or ramping down, decreasing? So it is expressed in units of power over time. Always, for example, megawatt per minute. This term is actually representing the rate of change of power. These rates, including the ramp up and ramp down rates, may be approached in two different respects. Firstly, these ramp rates can never be separated from the wind farms or photovoltaic station PV. Secondly, ramp rates also go for the energy storage system. This research, we found lots of advantages. First, it's environment. Renewable source integration can replace diesel generator, so we can reduce pollution. Societal, electricity in remote areas. Everyone can get power. No need to run very long cables and spend heaps of money, a lot of money to get everyone power. So in long distance, no need for cables. Improvement in reliability. Duration of outage decrease. And the most important thing in this study is economical advantage. It decreases energy cost, minimize use of expensive thermal power plant, flattening of electrical peak demand, power factor correction, transmission and distribution, and investment deferral. The disadvantage, site dependence of renewable source, site survey with long-term data acquisition and forecasting. Hybrid renewable energy system design, configuration and sizing of the hybrid system component with the objective, supplying the power reliably under varying atmospheric conditions, minimizing the total cost of the system, maximizing the system efficiency by efficient energy flow management strategies, optimizing through simulation studies under real operating condition for a reasonable trade-off among conflicting design objectives. Our challenges is the economic viability, cost-benefit analysis of hybrid system for reasonable payback period, real-world application, design of power conditioning devices with maximum power point operation of energy source, optimal energy management strategies, and their testing with laboratory prototype hybrid controller, development of hardware and associated software for field employment. We got our references from this site. Thanks for coming, thanks for watching, and I'll get back to you soon. Thank you.